Hi, I'm Frank Cohen of the Reflections Project. I did an experiment to see if a computing device can make sense of gestures made with the person's wrist. It identifies the fabulous 4 gestures of next, previous, accept, and cancel. It's extensible to train and identify additional gestures. It uses an ESP32 and an accelerometer. I developed a movement observation matching algorithm to make sense of a person's wrist movements. Human interfaces to computing devices often benefit from having 4 primary controls. I call these the fabulous 4 gestures. So, for example, next, a person's goal is to move to a subsequent choice, so you roll your fist counterclockwise to the left. Previous, the person's goal is to return to a prior choice. You roll your fist clockwise to the right. Accept. A person's goal is to approve a selection, so I adopted the American Sign Language movement to say yes. Take a hand and make it into a fist and bob it back and forth, resembling a head nodding. And finally, cancel. The person's goal is to disapprove a selection. I adopted the ASL to say no. Take your first 2 fingers and tap them with your thumb, resembling a mouth saying no. The serial monitor shows status and progress to recognized gestures. In the case where no gesture is recognized, the code shows basically just a message, inconclusive. The Movement Object Observation Matching Algorithm, or MOM for short, detects a person's wrist movements. It's a template system. It compares a person's movements to a library of recorded templates. Movement and template recording begins with detection of a person's movement. A variety of techniques then determine the movements from the templates. Templates last 2 seconds with 50 frames of accelerometer X, Y, and Z data and 40 milliseconds between each frame. Recording begins when the person begins movement. MOM uses multiple templates for the same gesture to identify gestures. The default settings record 5 templates for each gesture, then compare a person's latest gesture, their real gesture, to the templates. Settings in accelerometer.h control the type of gestures, the number of templates for each gesture type, the number of frames, and the template duration. MOM uses these matching algorithms. First, the sum of averages. It chooses the gesture type with the overall highest average matching ratio. The ratio must be 55% or higher to be selected. And secondly, highest average. This chooses the gesture type with the highest single matching ratio. The ratio must also be 55% or higher to be selected. MOM is extensible to include additional matching algorithms. Use Arduino IDE 2.3 or later to build the code. The code requires changes to be compatible with Arduino IDE 1.x and Platform I/O. We have these planned improvements to MOM planned. First, template effectiveness learning. MOM recognizes and promotes templates correctly recognized and denigrates and removes templates that do not recognize movements. It will do this by observing a person's movements after detecting a gesture. For example, when a person gestures previous after MOM detects a next gesture more than 50% of the time, it's fair for MOM to identify the next gesture as incorrectly identified. Second, we'll do automatic new template detection. MOM recognizes new templates from movements that do not match templates in its history. For example, when a person makes, say, 5 next gestures and then an unidentified new gesture and then another 5 next gestures, MOM will add the unidentified movement gesture as a new next gesture. Third, template sharing between people. So MOM shares templates with high success ratings among other devices. MOM has yet to be proven in the following instances. First, is there a difference in recognition between left-handed and right-handed people? Second, what impact does a benign or essential tremor Parkinson's disease, Alzheimer's disease, and say multiple sclerosis or MS have on gesture recognition? Third, do individuals gesture differently? Thanks for watching. This experiment is in the Reflections project. Reflections is an open source hardware and software platform for building entertaining mobile experiences. Details are at github.com/frankcohen/reflectionsos. Thanks for your attention.